Hi guys, Audrey here, and this is a JAC capsule on exponent rules. In this video, we're going to talk about negative exponents. Let's go. All right, so the important thing to remember about negative exponents is that they are just notation. All it means is flip the fraction. So when we're thinking about a to the negative m, no, that's not a fraction, but technically I could think of it as a to the negative m over 1. That negative exponent says that should be in the denominator. It's in the numerator. So a to the negative m is the same thing as 1 over a to the m. I just flipped the fraction. 1 over a to the negative n, same thing. That's a to the n over 1. I just brought it up. So that's the same thing as just a to the n. Now a over b to the negative m, again, flip the fraction. That's b over a to the positive m. I just flipped my fraction over. Now that negative m is applying to both the a and the b because those parentheses tell me so. Now we can use our other exponent rules to simplify this to b to the m over a to the m. Now your task for this video, for the moment you're going to have two of them. First, I want you to rewrite 4 to the negative 2. And second, I want you to rewrite 2 over 5 to the negative 3. And by rewrite, I really mean evaluate. What does that actually equal? So take a second, pause the video, try to use the rules to do it, then come back and we'll do it together. All right, 4 to the negative 2. That negative exponent says move it down. Since there is no denominator, we'll have a 1 up top, and that's 1 over 4 squared. And we know 4 squared is 16. So that's 1/16. Then 2 over 5 to the negative 3. That's the same thing as 5 over 2 to the positive 3. I just flipped the fraction over. Then our other exponent rules tell me that I can distribute that 5 to the 3 over 2 to the 3. 5 cubed is 125 and 2 cubed is 8. So that is my final answer here. Now with negative exponents, it's important to be careful about what they're being applied. So for example, if I have 5x to the negative 3, in this case, that negative exponent is only applying to the x, which means the 5 will not get brought down. So this is 5 over x cubed. That 5 stays in the numerator because it does not have that negative exponent. If, however, I were to put parentheses around the 5x, then those parentheses tell me that the negative 3 is applying to both the 5 and the x. So in this case, both the 5 and the x would come down to the denominator. So 1 over 5x, again, those parentheses are important, cubed. So in this case, the 5 is also being cubed. So I can think of this as 1 over 5 cubed, x cubed. That's just another one of my exponent rules. And 5 cubed is 125. So this is 125 x cubed. Now, when we have numbers already in the numerator and the denominator, for example, 2 over 3x to the negative 6. In this case, is the negative 6 applying to the 2? No. Is it applying to the 3? No. It's only applying to the x. There are no parentheses here. There's nothing to say that it should be applying to something else. So only the x to the negative 6 is in the wrong place. Right now it's in the denominator, and we want to move it to the numerator. That 2 and the 3 do not change places. So this is the same thing as 2x to the 6 over 3. Now, some people find this challenging. So the way that I like to think about it is when you have a constant like that 2 over 3 and the negative exponent is not applying to it, just move it out front. So 2 over 3x to the negative 6 is the same thing as 2 over 3 times 1 over x to the negative 6. So this is the same thing as 2/3 x to the positive 6. In the same way, up here, when I have 2x to the 6 over 3, anything in the numerator can be multiplied at the end. So I can think of this as 2/3 x to the 6th. It's on the side that x to the 6th, which means it goes with the numerator. If, however, I were to change this up just a little bit, so that 2 will still be on top, and I'll still have a 3 on the bottom and an x on the bottom. But now I'm going to put parentheses around that 3x, and instead of having a -6, I'm going to have a -2. So again, this 2 right here is the only thing that's not to the power. So I'm just going to bring that out to the front like we saw in the last example. So this is 2 times 3x, times 1 over 3x to the -2, which is the same thing as 2 times 3x to the +2. Now, it's important that I bring that 3x up because the -2 is applying to both the 3 and the x. The parentheses tell me that. No parentheses with 3x to the -6, the 3 stayed on the bottom. Parentheses with the 3x to the -2, so they both come up. Then that power of 2 can apply to both of these. We have an exponent rule that says that we distribute the exponents inside of multiplication. So this is actually 2. 3 squared is 9 times x squared, and this is equal to 18x squared. So just be careful about where that negative exponent is applying inside of a fraction, or if there is no fraction, what the constants that do not take the next negative exponent, what do they do? That can be a little bit challenging, so try to pay attention, and hopefully this made some sense and will help you to not make those mistakes in the future. All right, bye guys.